Going to look at today we are going to look at power factor. This is a course that is taught in power systems in electrical engineering. So let's go straight to the definition of power factor. Power factor is defined as the cosine of the angle between voltage and current. This is because when there is a reactive component in the circuit, it causes current and voltage not to be in phase. So when they are out of phase, then we shall have an angle between the two, and the cosine of that angle is now called power factor. We are going to look at the two situations that cause power factor to occur in a system. But first of all, let us look at a triangle. What is a power triangle? Well, this is a triangle that shows the relationship between the different components of power. We have apparent power, we have real power, and we have reactive power. Real power is actually the triangle is a right angle triangle. So real power is the working power, is what is able to be felt at the load, while reactive power is the one that is caused by capacitive or inductive components in a circuit. So those components they cause reactive power, while apparent power is now the summation of the two, the vector summation of reactive and real power. So as we've said, real power, this is the active component. It is expressed in watts and kilowatts, and sometimes in megawatts, depending on the unit that you choose. We also have reactive power, represented by letter Q in most of the cases, and is expressed in volt ampere, reactive volt ampere, VAR. We have also apparent power, which is expressed in volt amperes. You can also express it in kVA, and the reactive power can also be expressed in kVAR. So let us what do we mean by lagging and leading power factor? What is leading power factor? Leading, as the word suggests, it means that leading power factor, it means that current waveform is ahead of the voltage. So it means current is leading voltage. It is ahead, that means it is lagging. When we talk about lagging, what it means is that current is lagging behind voltage. It is behind voltage. So if you draw the two waveforms, you find that the waveform for current is behind the waveform for voltage. So we say that that particular type of power factor is lagging, and most of the components in the industry will find that they have a lagging power factor because of the inductors. These type of loads may include things like fluorescent lamps. They include things like inductive motors. So a lagging power factor signifies that the load is inductive. So anything that has an inductor, like the fluorescent lamps, the inductive motors, they consume reactive power. So therefore the power factor that is produced there is called lagging power factor. And anything that has a capacitor inside, or any capacitive load, supplies reactive power, so therefore it has a leading power factor. Let us look at the waveforms for lagging and leading. As you can see, the two waveforms for lagging power factor and for leading power factor. So watch out for the next video, where we will learn more about power factor. We will even learn how power factor correction is done, and much more, even the calculations on power factor. That is the end for today. Do a good day.